Hey guys, I have like 30 minutes right now, so I'm gonna try to solve one of the easy questions that has high frequency, um, difficulty easy, palindrome number. Wow, even though this is easy, the acceptance rate is pretty low. Search, insert position, 43, wow. Oh, I have to sort. Okay. Palindrome number. Oh, scary. Count all the odd number in an interval range. Wow, this is very easy. Big country. Big country. This question is tempting because it seems like it's a DP question. I don't know. Let's try this palindrome number. But I recently solved so many string questions. Maybe let me find the other one. Power of 2. Reverse follow string again. Complement to base 10. Complement to base 10 integer. Well, let me try this one. Palindrome number. Okay, given an integer, so blah blah blah, and then this is pretty high, so not sure this is good question or not, but given an integer x, return true if x is a palindrome, else false otherwise. Palindrome is an integer palindrome when it reads the same forward and backwards. For example, 1 to 1 is palindrome while 1 to 3 is not 1 to 1. I think I solved this previously. Okay. So we'll have integer. So here this integer is pretty long integer. There's a max of the, but although it's max number, if we convert it into string, it will not be very long. So one way is to convert it to string, and then second, once we have a string, there are many ways to compare palindrome. For example, we can maintain 2 pointers from here to this way and from here to this way, and then compare one by one if they are same. And then this one. Hello? I'm solving problem, coding problem. I don't feel hungry. Okay, I'm actually doing live coding. So, okay, bye. So how to convert int to string? So there is some thing like std to string, I guess. Let me try this first. Then the other way around is make a reverse of this string, but it needs the um, the length of this string is not very long, so having one more copy for the reverse string will not be a serious problem. Actually, this is a much easier solution. By having a reverse one and the original one, you can compare from here and then from here, one by one, actually until the middle. So pretty much the same with this one. But you can solve this only with standard library, like standard reverse or standard what is the name? Equal or is equal? Something like that. But the thing is, with the 0, 1 from the okay. Another way around. Let's say the string is 1, 2, 3, 2, 1. So we know this, but we don't know this. The way it is that the maximum is 2 to the power of 31 minus 1. So this is some number. This is some huge number. And then let's say that this is this much number. And then these are, and then in this case, this is 10, 0, 10, 1, 10, 2, 10, 3, 10. So if we know this, then we can compare the compare this one and this one, and then compare this one and this one, right? So this way we don't need to make any storage. We don't need any storage. Let me start the timer. Okay. Maybe I spent like 5 minutes already. So let me try this easy one, and then maybe I can try this one too. So in this case, you need to know whether, let's say that this starts from something, and this is somehow 10 to the power of x. So we can use some log function to find out the value of x. This seems kind of too much. Let me try this second version first. Get answer string. This is, well, it is difficult to define n, but let's say that n is the number of digits in decimal number. So in that case, let's just say this. In that case, our goal is I don't know, string s num equals standard library to string x. So, and then string reverse equal so this is num actually, and then we'll make a reverse of this string, okay, and then return standard library is equal so there's no is equal, maybe this or equal. So num begin plus num dot size 2 rev dot begin. So here if the size is 3, then the middle one will not be compared. It's 2, the first one, only the first one will be compared. Okay. So here, if x is negative, then we return false, right? And here, if num dot size equals 1, we return true. This is a quick decision, right? Then we're gonna return get answer 1x. So we'll run this, accepted, submit. Not bad. And we'll try the second solution. 2 4 power 0 to something power plus. So first what we're gonna do is that so if the number is 1111 and the power is 0 and then 1 2 3, so this is this. So until here we'll get the what is this, dividend, and then this will be quotient, I don't know. And then when it is equals to 4, then we'll get 0, right? Or the remainder will be the same as x. So if and then since this might goes up to the scope of the integer, we'll define this 10 power equals um, initially this is 1, and then after this will be multiplied by 10, right? And then if x 10 power equals 0, so initially it's 0. This means that, well, can return check is a palindrome x, and then power minus 1, right? So here we can define is auto is palindrome int x and then int power, and then like this. So this will return true. Let's say false. So what it does is that, so now in here power is 3, and then we have, and then power is 0. So for int I equals 0 to I less than power 2, just like the one in the above, we will increase I, and then what we're gonna do is if this one, if x power instead of power, can we because if we pass power, we need to calculate the power inside here, which takes a little bit of time. So instead of doing that, we can pass 10 power 10, right? And then this will be int, but since this is long will be passed to the int power, and I guess this must be okay, right? So we may need some assert between here, but we're okay. So int small 10 power is start from 1, int big 10 power is power, big 10 power, let's call it big 10 power. It's not very good name, but anyways. So let's do this true because let me refactor this later. So what we're gonna do is if x big 10 number power is equal to x to this from 10 small 10 number small 10 power, if those are same you're okay. If those are different then false, right? And then in this case big 10 is this one, small 10 is this one. Next step, big 10 will be this one. Small 10 will be this one too. So when they and then what we should do is that big 10 power decrease the big 10 power and then increase the small 10 power like that. So let's do this again. So big 10 here 1 2 3 4 no 0 1 2 3. Here small 10 is 0 1. Next time it will be 2, small 10 will be 2, but we have to do this. And then somehow small 10 power will be larger than, so here small 10 power is big 10 power, right? And this, if everything is same, true. So let's call it get number 2. Let me check. So we can do the same here, and then if this is smaller than 10, we should return true, right? And if this number is 2, 2, so here we will see 2 TC. One is 2, 2, and another is 2, 1, 2. Okay, 2, 2. In case of 2, 2, this is 1, so power is initially 0. We don't need this power, right? So this is actually while true. Power is 1. The 2, 2 divided by 1 is not this one. So we should multiply. So 10 power is now 10. Still, this is 2. And then it will be 100. So 100, this is 0. So let's do this with 2, 2, and then this will be 10 again. So 2, 2, 10, and this is 10. So, well, this is barely true. So So 10 is 2, and this should be not this, it is. Okay, so this is the same, so we'll do this, and big 10 is decreased, and then smaller 10 increased, so yeah, true. So in case of 2 and 2, likewise, this 10 power will be 1000, and then this will be 100. So this is 100, and this is 10. This is okay. So 100, so this is 2, and this is 10. So we'll have 2. These are same. So now big 10 is decreasing to 10. Small 10 is increasing to 100. So this will be false. So we'll return true. Right? Yes. Wrong answer? 1001. Okay. 1001. So when it is 1, 10, 100,000, and 10,000 is 0. So 1000 will be entered in here. So this is 101, this is 10,000, right? So 10,000, this one. Oh, yeah. The problem is that when you go here, the answer will be 10. Then the remainder will be 10. So this will not be true. So instead of doing this, how can you get? Okay, here. How can you get this number? Oh, the I thought that we can eliminate this by dividing by 1000, and then we can eliminate this. You know, can get this. For example, like let's say that 3, 3. In the case, we can remove this by but when you remove those, the big 10 and small 10 is not true anymore, right? So in case of big 10, getting 32 as big 10 is. But if we remove 3 somehow by subtracting this from the x, we'll get this number. But here reminder is now 2, 3. So we also need to handle this 2, 3. This is way complicated. There's gotta be an easier way. So this number. Um, mm, so my question is, how can we extract this number? To extract 2, what, and then what you can do is remove this by then by doing this, and then by doing this we can get this. And how about this? The same. So small, in case of small 10 power, okay, when small 10 power is initially is 10, and then it will increase by 100. In the case, by doing reminder, we will get this, and then minus 10 by doing this, we'll get this, right? It's a bit awkward though. So this one, so big 10 number is currently this one, and this is a big 10 number, and how can you get 2? This is also similar, but okay. 10. Then we'll get this, and then can divide this with a big 10 number. Ah, this is wrong. Ah, maybe I need to make some get digit int x int radix, such a function. Yeah. So so this means that 10 power. This means that if we have 4, 3, 2, 1, and then 10 power is 100, extract this value, right? So what we can do is that int reminder x percent 10 power multiply 10. So now this one will get it, and then digit 10 power, right? So this is the value. So here get digit. So small 10 is currently this one, and then maybe we need to rewrite this, and then if get digit x big 10 power, if get digit x small 10 power, and if this is not, then we return false. And then we're gonna do this. So the question is, does it work with 1? So let's do this. So this value. So multiply. So we'll get this one, right? And then this one divided by 1 is okay. So this works. And then we need to find the condition. So let's say 1 to 1. This one. So first, we start from this and we start from this, and then I will multiply 10. This will be 10. So whenever they are same, we don't need to do that. What happened with this one? So 1, 10, 100, 1,000. So at first turn, values are this, and then second turn, this and this. So big is still big. So here, and this one, so this means that big 10 power, small 10 power. So when they are same, you don't need this loop, right? Like that. So code is. Oh, what? Sign the integer overflow. Oh, yes. Static cast wrong. So now this will be fine. Yes. Phew. So it took me some time to figure this out. Yeah. But it works. So I think that's it for today's session. Okay. See you next time. Bye. Oops.